You're watching a Hanford Communities issue briefing, highlighting important environmental cleanup issues at the U.S. Department of Energy's Hanford Site in southeastern Washington, issues affecting citizens of the Pacific Northwest and the nation. The Hanford Communities organization was established in 1994 and is comprised of the communities surrounding the Hanford Site, forming one voice to advise the Department of Energy on important transition and cleanup issues.
Beginning in the 1940s, the Hanford Site in Washington State produced plutonium to be used in nuclear weapons. Over the next 4 decades, that production effort resulted in the generation of 56 million gallons of chemical and nuclear waste that is currently being stored in 177 underground tanks on the site. The management, treatment, and ultimate disposal of the waste is part of the environmental cleanup effort managed by the U.S. Department of Energy. DOE recognizes the urgency of the cleanup mission and the need to make safe and efficient progress. The tank waste cleanup mission is being accomplished using a phased approach, beginning with direct feed low-activity waste, or DFLAW. This approach maximizes near-term risk reduction and begins disposition of the most mobile constituents of the tank waste. The Hanford Site encompasses more than 580 square miles along the Columbia River in southeast Washington. Each of the underground storage tanks at the site contains a unique mixture of chemicals and radiological waste from multiple processes during the site's production mission. To now, the focus has been on the design and construction of the waste treatment and immobilization plant, which will vitrify some of Hanford's tank waste. Today, however, that mindset is shifting from designing and building to starting up and safely operating the facilities needed to begin making glass with the DFLAW approach. Waste treated from single-shell tanks and transferred to double-shell tanks is being consolidated in the AP Tank Farm in Hanford's 200 East area, where the tank waste will be staged for treatment. From the AP Farm tanks, the waste will then be fed to the tank-side cesium removal system, or TSCR, which will utilize technologies safely operated at the Fukushima cleanup in Japan and the Department of Energy's Oak Ridge site in Tennessee to remove cesium and prepare the tank waste for immobilization in glass. By developing tank-side technologies for tank waste treatment, DOE is generating a more efficient and cost-effective method to treat Hanford tank waste that will inform decisions about how best to provide treatment capability over the life of the effort. The flexible and modular configuration of the TSCR technology, which uses a proven ion exchange process, will allow DOE to provide a reliable initial feed for treated waste as other strategies are evaluated. The cesium removed from the tank waste will be captured in ion exchange columns and stored on a concrete pad adjacent to the TSCR facility, while the treated low-activity waste will be returned to a separate tank, known as AP-106, for transfer to the low-activity waste facility. The waste will be transferred by pipeline to the low-activity waste facility, where it will be mixed with glass-forming materials to produce a solid glass, or vitrified waste form, in stainless steel containers. Each batch of waste sent to the low-activity waste facility will be sampled at the analytical laboratory to determine the recipe of glass-forming materials needed and then verify the vitrified glass meets regulatory requirements for disposal. From there, the containers of vitrified low-activity waste will be transferred to the on-site integrated disposal facility for long-term disposal. Over the first 10 years of operation, the DFLAW approach is expected to yield a number of important benefits for the Hanford cleanup mission, including an overall 24% reduction in the long-term environmental risk of the tank waste legacy. This approach allows DOE to begin the treatment and disposal of the most mobile constituents of the tank waste, and will provide valuable lessons learned to aid startup and commissioning of other portions of the waste treatment and immobilization plant, which will address the high-level tank waste. DOE and the Hanford Site contractors are aligned and integrated, focused on delivering the waste treatment capability needed for waste immobilization and final disposition of all Hanford tank waste. The Department of Energy has reached a critical point in the DFLAW project with the start of tank waste treatment just around the corner. The department is working to strengthen relationships across contractors, regulators, national laboratories, and our local and regional communities that will enable us to start treating waste as early as 2022. The success of the DFLAW project will be the result of years of dedicated efforts by so many to the long-term safety of human health and the environment, and will mark a significant achievement in the overall Hanford cleanup mission.
It's an exciting time for Hanford. We're getting close to starting up a major facility, a major processing facility, which, since Purex has been down, this is a major operation activity. So we're really excited about that and getting it moving. Low activity waste has been contemplated since about the 2006 time frame. Lots of studies since 2006. And in 2012, we had technical issues at the high-level waste facility and the pretreatment plant. So we decided that we wanted to start up the 80% of the WTP, and that included LAW and the balance of facilities. So we entered into agreement with the state through the consent decree on starting up LAW in 2023. And since then, we have a new capital facility called Low Activity Waste Pretreatment System, which has been changed to the Tank Site Cesium Removal System. We'll talk about that as we go through this. So let's look at our placemat here, and we'll start from the left to the right. So you can see on the left the AP farms. Those are the newest farms that we have. They were built and put into place in 1986. So the feed from those tanks will be going through low activity waste. So for the first 5 years, we anticipate about 5 million gallons of tank space will be created through that process. So you can see that there's 4 tanks here that we're going to have to upgrade. So we're doing design of the upgrades of those tanks right now to put new pumps in, new piping, infrastructure to feed LAW. And the advantage of doing low activity waste first is we're going to create double shell tank space. So instead of building new tanks and using that capital to build new tanks, we want to process the waste and the ultimate disposition of the waste. So over a 10-year period, we think we're going to get about 12 million gallons of tank space, which is pretty significant. In addition, low activity waste is a lower hazard category than the pretreatment high level waste. So if we get our processes, procedures, people trained, and operate that facility first, that makes a lot of sense before we go into the higher hazard facilities. So you can see the upgrades there. That feed will go through what we call tank side cesium removal. And that's probably a change from what you heard before, which was low activity waste pretreatment system. And the reason was the delivery of the low activity waste pretreatment system wasn't going to happen in time to meet the consent decree milestones. The design got too complicated, and construction, it became a major facility. So what we did is leverage the Fukushima technology and the technology from Savannah River ticker. We try to avoid the word closure in our acronym. So we went tank side cesium removal system. It's an at-tank system. It's designed for about 5 years. When we start up, WTP has a ramp-up rate, so it's not going to start out at full capacity, so it's going to ramp up over a certain period of time. So we believe this system will provide, at 5 gallons a minute, enough feed to deliver enough to get through a 5-year period of time. And then we'll have to make a decision on what the final design could be. It could be this system with permanent piping, because right now we're going to use hose and more of a, not a permanent system. But this will inform the final design of the way to remove cesium out of the feed. So TSCR, we actually awarded a contract to Avitech out of South Carolina. And if you've read the news lately, they have teamed with MCE, which is a local company. They bought that company. So they'll be doing the fabrication and testing. So that's been awarded, and we're in the process of getting a decision to get the infrastructure into the tank farms also. And we're trying to get this online by 2021 so we can process about 1 million gallons of feed to support a 2022 startup of low activity waste. Is there any questions on the TSCR concept?
So I know that the TSCR equivalent for Savannah River was manufactured in Richland. Was MCS involved in that?
That was Columbia Engineering.
Columbia Engineering. And so you went with a different company that had Fukushima experience versus the company that had the Savannah River experience.
Right, so we put it out for bid, and we had 3 bids on it, and through the evaluation process, we went with this company based on mainly technical criteria. And they have a lot of experience with Fukushima. They actually moved cesium out of the water from the reactor issues they had. And you can see that one of the changes that went from low activity waste pretreatment system to the concept we have now is what we call elutable versus non-elutable ion exchange. What we were doing before was elutable, which means that we wash the cesium off the ion exchange column and put the cesium back into the tanks. Now, once we remove the cesium, you can see that ion exchange column pad there. We will be storing those ion exchange column until final disposition, and that disposition could be a repository, or right now we're thinking once the high-level waste melter comes on board, we can process that through the high-level waste melter. And Savannah River's looking at the same thing. So as we move to the right, you'll see low activity waste facility. And this is the facility where you put the glass formers, mix it with the waste, heat it up to 2100 degrees, and pour the glass into stainless steel containers. Everybody thinks it's canisters, but canisters are high-level waste by definition. And so we call the low activity waste canisters, but they still are stainless steel. And you've been on tours out there probably and saw the containers to the right of the facility out at WTP. So we have just finished validating what we call physical construction complete, which means most of the construction's complete. We don't have the control systems in place, and there's some other exceptions, but for the most part, LAW and the balance of facilities in the laboratory are nearing construction complete. We call it physical. All the mechanical and civil work has been completed, and a lot of the wiring's completed. Some of the terminations still have to be completed. And the good part is we've kind of pivoted to turning from a construction into a startup mentality. We've turned over 50% of the systems from construction to startup, and we've turned over 5 facilities from startup to operations. So we actually are on permanent power. We have water systems in place, and we're slowly turning over steam, compressed air, and those others from startup to operations. 50%, like I said, are in the startup mode. So the plan out there is significantly changing. If you walked into LAW facility, it's hard to get around now because all the doors are in place, so it's not really wide open. It's all drywalled in, and the doors are in place so we can do HVAC testing. So it's pretty exciting. which means we have a change in workforce also. So we're changing from construction into operations mode. So we're in a transition there also, and bringing up, conduct of ops principles and other things. So we have cultural changes that are ongoing. When you're going from construction to operation, there's significant cultural changes. And then for the other part is the analytical lab. We've got an operating permit. We worked with the state and they issued us an operating permit for the lab. And we gained lessons from that because we have the effluent management facility, which we'll talk about here in a second. We're going to ask for an operating permit for that and LAW. So going through that process, working with the state, collaboratively with the state, and we appreciate their work on that. We got that permit, which is significant. So you can see everything's focused on operations right now. We still have construction, but we are really focused on pivoting to the operations, which is significant. So on the top right, you see the effluent management facility. That is coming along. The purpose of that is when you process waste, you generate a lot of water from your off-gas systems. Up to 2 to 3 gallons of water is generated, or secondary waste is generated for every gallon of waste you process through the system. So this evaporator used to be on the front end of pretreatment. Instead, we moved that evaporator to be a lone evaporator to evaporate that water off. It's a huge water management issue when we're processing this. And this is kind of the critical path to getting to LAW startup, since it's a new facility. But all the walls have been poured. We're getting ready to place vessels, and this is on schedule to support that. So as part of making that decision, this facility had to be constructed. So it is on critical path. And then to the right, you see the low activity waste plant. Like I said, we just validated the construction complete milestone, physical construction complete, continue to do testing and turnover of that facility, and we're looking to get this started up as soon as 2022. There's other activities that's important to know also, is not only in our budget, we have to be aware, but for Richland Operations Office, they have significant support to this. They have the water systems that have to be upgraded, power. Right here you see the integrated disposal facility on the bottom, in the orange bottom right. The integrated disposal facility is where all the glass containers are going to be stored, and the secondary waste, that final waste form will also go into that facility. So that has to be permitted, it has to be licensed, and some upgrades to that too. So Richland has some significant upgrades that we watch as the budget gets approved every year to make sure that that's going to support our operations. And a lot of people don't realize that. So when they come in $100 and something million low for the year, we all scramble to make sure that we're going to be supported as part of our startup.
Please. Quick question. And that facility is located where?
It's
Are they all out there in the west area?
East area. So do you know where Purex is? It's kind of behind that.
As you go from construction to operations, it has an impact on manpower and workforce. What kind of impacts, and when should the community expect a little bit of a transition to actually impact this?
We're actually ramping up startup engineers right now and operations engineers. If you've seen our budgets though, high-level waste has actually been plussed up. So we're looking to minimize any impacts to engineering, design engineering, by rolling them over to the HLW facility. We were kind of looking at transition plans, and we do all the time, because that takes,
it's going to happen. So
it takes significant notifications ahead of time. So we do plan those way ahead of time. But with the plus up in HLW in 18 and 19, there'll be minimal impacts, I would say, to There's going to be some, but less than what we expected. I don't have exact numbers at this point, but
Something that we will maybe feel, but not much, or, you know, there's a big difference between 5% reduction and 20% reduction
Right.
in manpower. So any guesstimates that you have would be helpful for us in our planning, I think.
yeah, and we can get those notifications ahead. I just don't have them on the top of my head. I know the curves. I've seen the curves, but we are ramping up, and some of the same skills that you would use for engineering, you still need field engineering and other things. So, but like I said, like instrumentation control engineers, they're going to be around for a long time, troubleshooting those systems. But civil engineers, we're through the civil engineering process, other than HLW, and so that transition to HLW is important.
Thank you, I appreciate your comments.
One more question. The integrated disposal facility, I see that as it's basically a big pit, correct? And is that pit, have the containers been proven and tested to, I mean, I don't know how long they're gonna last, but is there a liner in that pit, or how does that?
There's several liners in the pit, and there's pumping systems, because once you have the liners, then you get a bunch of leachate in there, so you have to pump the water out and then treat that water. But what we do is go through what we call a performance assessment. So we look at what the leach rates out of glass are for the constituents that are in the glass. And we're actually developing that performance assessment right now. And we look at 1,000 years and 10,000 years impact on the groundwater from conservative modeling.
Any additional questions for Ben?
How do you get started when it's 2022 and you're ready to go? How do you get approval to start the operation, or what do you do then? to get approval?
So that's a lot of our work right now. No, we go through, the first step is we got to put all the programs in place, be it emergency preparedness, all that. We have a whole organization under, it's called, we have an operational organization, and right now we're going through, because the key is you don't want to get to the end and go do a 2-week review and say, we're done. So we're already doing the reviews starting now of all the program developments to get into operations, and it's called a line management review. And then the contractor does their own reviews as they go through the system. And then they make a recommendation to me. I'm actually the startup authority to go ahead and do a readiness review, which is independent, to go verify procedures, processes, and people. And after that review, you decide if you're going to start up or not based on the risk. So the key is we go into a cold commissioning phase. There's not as much radioactive concern as there is chemical concern, because there's a lot of chemicals in this. So usually you would do this review for hot commissioning, which would be entering radioactive operations. But we have to do reviews ahead of time because of all the chemicals in that. That's the hazardous constituents is what we're really worried about if you look at our hazard analysis.
Well, it's my understanding that 80% of the waste is going to be put through this low active waste facility. That's a big jump, and it's going to be very important.
It is. If you look at, we got 56 million gallons. Some of that's in salt cake, so we have to dissolve that. So it's not 56 million gallons, it's 160 million gallons of waste we process. And like you said, most of it goes through low activity waste, but it's always been envisioned there would be another supplemental treatment, because pretreatment actually generates so much low activity waste, you need a supplemental treatment to keep up with it. But through glass formulation improvements and other improvements, what we envisioned for that supplemental treatment was, years ago, was going to be 3 times the size of that LAW. We've reduced that to less than that right now, and we continue to try to make improvements so we don't have such a supplemental treatment need. But it all hinges on when do you want the mission done. right? I can extend the mission and run everything through there, or I need some kind of supplemental treatment to get the mission done earlier, because that's what drives, high-level waste drives the mission if you have enough LAW capacity. LAW drives the mission if you don't have the capacity there.
Yeah, well, I think the state's super excited because there is very much progress on direct low activity waste ahead of the consent decree deadline of 2023. And our team, I think, has been indicated, we've been working really well together with the Department of Energy on all the permitting and things necessary for this. And I think the big change for us was going from the low activity waste pretreatment system that they had originally envisioned to the TSCR. We still, I think we're still learning about TSCR. It's still being designed currently, and so we don't have details yet on how it'll operate. Little bit of concern that it's got a really low flow rate compared to what the low activity waste pretreatment system was going to do, and just want to make sure that once we've got all these systems ramped up that we're really optimizing them, that we're using them to their capacity to the extent we can. So we'll see, along with Department of Energy, how TSCR works, and then I think they were anticipating, as Ben said, a 5-year life, and then they would make another decision about whether do we need a low activity waste pretreatment system that's scaled down from what was originally designed, or just do we use more TSCRs. Prior low activity waste pretreatment system had, as Ben said, the elutable resins. So you basically wash the cesium out and you reuse the resins. And so now that you go to a non-elutable resin that captures the cesium, holds onto it, you now have a new waste stream. You need a high level waste. You need to figure out what you're going to do with. And so we will now have additional waste that's going to be stored on site until that final disposition pathway has been decided. And
So Alice, when you use the term high-level waste, that can mean a lot of different things to a lot of different people.
yeah.
And if you could explain what you mean by that.
Yeah, it's the cesium. It's the high rad content materials, and it's what would be taken out in the pretreatment system when that's for when the high level VIT plant is up and running. But it's basically whatever needs to go to either a deep geologic repository.
That doesn't exist.
That doesn't exist.
Yeah.
Yeah. Or be somehow vitrified and then go to the deep geologic repository.
That doesn't exist.
That doesn't exist.
So, so we're looking at basically being a storage facility until the country gets their stuff put together.
Well, I think we have been working with the department on the integrated disposal facility where this glass that is made in the low activity waste facility will be stored, and wanting to make sure that, because the plan has always been that low activity waste, once it's turned into glass, will stay at Hanford forever, that really is a robust facility, and that we've made sure that the glass and the canisters and the storage facility itself will make sure there's no leaching of those high hazard contaminants out into the groundwater. When it comes to the high level or high activity stuff, I think the state is always going to be trying to beat the drum for Yucca Mountain or an alternative deep geologic repository to the extent there is one that's cited. Aside from that, I'm not sure what else we've got in the works to try to solve these problems.
So we do have facilities that you would put the high-level waste in. If you go out there and see where the spent fuel was, that was supposed to be the high-level waste canisters from Hanford Waste Vitrification project back in early 2000s, late 90s. Savannah River's got the same issue, right? They've got storage facilities, and they have to build additional storage facilities to do the additional canisters. I can't solve the repository issue. It's a political issue, but I can tell you that once it's in glass, it's in a stable form, it's not in the tanks, it's less risk. So it's better to have it in those facilities than in the underground storage tanks.
To find out how you can become more involved in this important regional issue, or to have a Hanford Communities speaker talk to your organization, contact the Hanford Communities at 509-942-7348 or visit our website